before we actually kind of look at the graphs and look at a problem. So a parametric equation, you see some different words in there, but the word I want you to focus on is parameter, because that's where it comes from. And parameter is another way of saying a variable. Now specifically, this third variable we're going to think of as a helping variable. And in our case, and in most cases when you deal with parametrics, usually this variable is represented by the letter t because we're looking at the movement of an object over time. Now, how this is different from a normal function. And those of you that are doing the honors projects, maybe here's a way you can connect it to functions and inverses. Instead of y being a direct function of x, because that's been your life in math up until really today. You have an input, you have an output, you have an x and a y. Here's where a parametric is different. X and y are both functions of the parameter t. So we can relate x to t and we can relate y to t. There's a common element because both of them are moving over time, right? The wind blows across time, the gravity goes across time. You combine those together, that's their relationship, that's how they're linked. What this allows us to do, and we'll look at the algebra behind this in a sec, this allows us to express two related motions, and those motions being horizontal or vertical, kind of what we've been dealing with vectors too, an x and a y, and we represent these separately with respect to time. So again, time is kind of our common variable. It's what connects these two. I'm going to draw a little sketch at the bottom just so you guys can see it. Let's just say here's your path. Here's your x movement. Here's your y movement. And this is kind of... Are you guys having a hard time reading my words? You making fun of my handwriting? Separately with respect to time. Alright, so let's just say this. Here's an example of a parametric, and you guys did this with McFreeze. So here's your example. This is going to take up not much of the page, but I'm only going to give you probably one example. Eliminate. Do we have space on the top? Should we use it? No, just use the bottom. Eliminate the parameter and identify the graph of the parametric curve. First one is this. X equals 1 minus 2t. And the second one is y equals 2 minus t. Now this is kind of like your Siegel problem, except it's a little bit simpler because I want to illustrate a concept versus like just dealing with crazy math. Your calculator, you can put this in your calculator and it'll spit out a graph. Okay, x1, y1. How do we do this algebraically? What's in common between the two? What variable? T is what relates the two, right? So how do you think we can construct a final equation that relates the two? Yeah, what are we going to do here?
Can you just substitute it by making this one equal to t?
You're exactly right. We need to use substitution. Now, this one looks easier to get t alone, right? But we're not going to use this one because when you graph, y is always alone, right? So I want you guys to get t alone in this equation. Isolate t for equation x. So you got to get t alone. So I'll let you guys do this. All right, Kelsey, what's my first move?
Oh, it is negative.
Subtract 1, subtract 1. Toast. Got it funded too, man.
You still funded too?
I did. I got 2 projects funded. Uh-huh. All right. What's the next move? You guys tell me. Yeah? Divide by -2. All right. T equals, all right. Now, with this -2, you got to be careful with it. Sign switch, right? So it's going to be -x plus 1 over 2. Y equals 2 minus, now put all of this in parentheses, -x plus 1 over 2. How do we deal with this 2? We've been practicing this skill all year. We have to get a common denominator.
Yeah.
So what do we multiply it by? 2 over 2. Y equals 4 over 2 then, minus -x plus 1 over 2. See if you guys can finish it up. All right, you guys got to distribute this negative. So we end up getting y equals 4 plus x minus 1 over 2. The negative gets distributed to both. And then what can you combine? 4 and 1, so you get x plus 3 over 2. The beauty of this is your calculator does all this for you. But now, did you get rid of t? Yeah, so could you just put this in your calculator and see what it looks like? Yeah, but if you did that, you need to be in function mode, not parametric. Parametric, no, I'm not going to do it. A parametric, you'd put in these, you would get the exact same graph as you get here. All right, so this is all just substitution. It's algebraically doing what your calculator does for you. What was that?